Hi, so in this video we are going to take a look at a concrete example how quicksort works. Okay, so we have a one-dimensional array we would like to sort 23, 6, 4, minus 1, 0, 12, 8, 3 and 1. Okay, we call this quicksort method with this array. The low index is 0, the high index is the length of the array minus 1. Of course this is not true, so we have to partition it. So the pivot index is the middle item, which is the 0. We have to swap the pivot index with the high index, so we swap 0 and 1. Okay. We create an I index and initialize it to be the low. What's the low? The low is the 0. And we iterate through from low to high and check whether that given items are greater than the pivot or not. Because the high index after the swap operation is the pivot basically. So 23 is smaller than 0. No, we keep going. 6 is smaller than 0. No, we keep going. 4 is smaller than 0. No, we keep going. Minus 1 is smaller than 0. Yeah, so we swap the I and the j index. J index is minus 1, this is the index of the for loop. The I index is initialized to be the low, so 0. We swap the two of them and we increment the ith index to be 1. And we keep iterating. Okay, 1 is smaller than 0. No. 12 is smaller than 0. No. 8 is smaller. No. 3. No. At the end, we swap the I with the high index. What's the high index? Because we have swapped the pivot index with the high index, we know that the high index is basically the pivot item. So we know that after the swap operation, this is the pivot we have chosen at the beginning. So we have managed to rearrange the array so that on the left side of the pivot there are the items that are smaller, so minus 1 is smaller than 0, and all the items 4, 23, 1, 12, 8, 3 and 6 are greater than the pivot item. Okay, this is the aim of the partitioning. And we know for sure that this item is in its final position, so we consider it to be sorted. And we recurse on the left subarray and the right subarray in a recursive manner. We just call this quicksort method with recursion. Okay, it has a single item, so it is sorted by default. What about the left subarray? Okay, so as you can see that we delegate the same array, but the indices are going to be changed. Okay, so as you can see, we just have to consider this subarray. Okay, what about the pivot index? It's going to be the middle item, the 12. Okay, we swap it the pivot index with the high index. And again, we initialize an I variable to be 0. Okay, it is 0 in the subarray. If we consider the whole array, this I is equal to 2 because 0, 1, 2. It is a matter of implementation. So in this case, I say that I is equal to 0 because we consider this array without the green buckets. Okay, so we have to iterate through from low to high and check whether that given item is smaller than the high index. 4 is smaller than 12. Yeah, it is. So we have to swap I with j and we have to increment the I value. Okay, what about the 23? 23 is not smaller, so we keep going, but 1 is smaller than 12, so again we have to swap 23 and 1. Okay, and we have to increment the I value. Okay, what about 6? 6 is smaller than 12, so again we have to swap, and we have to increment the value of I. What about 8? 8 is smaller, so we have to swap, okay, and we have to increment I. And 3 is smaller, so again we have to swap and we have to increment I. And in the end we have to swap I with the high index. So in this case we know that this 12 is going to be in its sorted position. And we recursively sort the left subarray, so the items that are smaller than the pivot and the items that are greater than the pivot. Again we choose a pivot item as the middle item of that given array, and we have to swap it the pivot index with the high index. We have to initialize the I to be 0, and again we iterate through all the items and check whether 4 is smaller than 6. Yeah, it is smaller, so we have to swap, okay, in this case we have to swap 4 with itself, and we have to increment I. Okay, 1 is smaller than 6, yeah, so we have to swap 1 with 1 and increment I. What about the next one? 3 is smaller, so we have to swap 3 with 3 and increment the I. And 8 is not smaller than 6, so nothing happens. And we have to swap the I with the high index, so 6 with 8, and we consider this 6 to be sorted. It is the pivot item, and we call this quicksort on the left subarray and the right subarray. Okay, what about these 3 items? The middle one is going to be the pivot item, and we swap it with the last item. Okay, we initialize I to be 0, and again check. 4 is smaller than 1. No, we keep going. 3 is smaller than 1. No. Basically, that's the last item we have to consider, and we have to swap I with the high index, and we have to return the pivot. Okay, so 1 is in its sorted position. What about 3 and 4? We choose the middle item, we swap the pivot index with the high index, we initialize I to be 0, we iterate through all the items. In this case we have just 2 items, the 4 and the 3. 4 is smaller than 3. No. So basically that's all about it, and we have to swap I with the high index, and we consider these 3 to be sorted. What about 4? 4 is just a single item, we consider it to be sorted. 8 is just a single item, so we consider it to be sorted. And 23 is just a single item, so we consider it to be sorted. So this is how quicksort works. As you can see, it's quite easy to implement it. We just have to generate a pivot item, whether at random or we choose the middle item. We have to swap it, initialize the I, decide what's going to be smaller than the pivot and what's going to be larger than the pivot, have to make another swap, and then we have to call the quicksort method on the left subarray. So on the subarray containing all the items smaller than the pivot, and we have to call the quicksort recursively on the array containing all the items that are greater than the pivot. So that's all about quicksort. Thanks for watching.